everybody. It's day 3, the second block, the second session. So I hope that you are still all awake. It's my pleasure to be the moderator of this session because I am someone loving working on transport and I am a telecom engineer. And so for me, it's a pleasure to moderate this session, which is on what can 5G brings to each mode of transport. We have had just before a specific session on 5G for connected and automated mobility, so the road part. And here we will go a bit beyond and discuss on specific modes so that we can have the full picture. I need also to inform you that this particular session is web stream. So if you do not want that we see you, I invite you now to leave the room. If not, you have given your consent to be web streamed. Or with the back to the camera. Or yes, you put your back at the camera. Joke aside, so we have a heavy agenda. And so I would like to start immediately with our keynote speaker, Mr. Lauri Oksanen, who is Vice President, Research and Technology at Nokia Bell Labs. Mr. Lauri Oksanen, I invite you to come and give your keynote.
Okay, thank you, and good morning, or still good morning, everybody. Great to see you, so many of you here, and thank you for the opportunity to give the keynote here. At Nokia, we work a lot on 5G, obviously, and we believe it's a really important technology also for transportation. I say also because one of the key factors is that 5G actually is the first mobile technology that has been specifically designed to serve all kinds of different purposes. So transport is one of the use cases, a very important use case, both for massive IoT, for entertainment, and for critical IoT. So all the three corners of this famous triangle from ITU. So, but the important thing is that 5G is really multi-purpose platform. So you have to build basically, either you can build one network in a specific area and use that for all the different use cases, including transport. And I'll tell you a little bit how that is possible. Or the other way to look at this, that because 5G can be used for all use cases, from very simple connectivity to consumer connectivity to very critical, high reliability, low latency connectivity, there will be a huge scale benefit of 5G over any other technology for connectivity. No other technology will be used so widely for wide area connectivity especially. So that means that 5G will be by far the most economical technology for most of the connectivity needs, and will be able to serve those. So it's really important to understand that 5G is not just another new version of a mobile network, but it's a totally different mobile network designed for connecting really everything. So the top part of this is the traditional extreme mobile broadband, which 4G is already doing pretty well. 5G will improve on that for consumer use cases. The lower left corner is the massive machine communication, which is starting now with 4G networks already, connecting a lot of devices with lower cost and very low power consumption, available in simple sensors everywhere along roadsides, etc. And the lower right corner is the critical machine communication. In the original ITU picture, at the very lowest right-hand corner, there's actually an example of automated driving, which requires really low latency and high reliability when taken to the extreme. So 5G will cover all these different use cases where all the previous mobile generations only covered the top part of this diagram. So that's the big difference now. And if we look at what 5G specifically brings for transportation, there are a lot of new things. Starting from the left on the top, new spectrum bands. A lot more spectrum for capacity and different use cases, also in very high ranges, like in the millimeter wave, and but also will come to the lower bands. So there will be wide area coverage. For example, in USA, one of the operators plans to have wide area total country coverage with 600 megahertz, which is lower than, for example, lowest mobile bands at the moment. So 5G will also do wide area coverage with low bands. but there will be a lot of capacity with the new bands. So it can really be a future-proof solution from capacity and coverage point for long into the future. Highest reliability, so 5G will really extend the typical, let's say, 3 nines or so to 5 nines or even 6 nines reliability for specific use cases, which has not traditionally been possible with wireless technologies. There are several technologies how that is enabled, which I will not go into, but this also extends into the core part. So the part which runs on cloudified networks, not just the radio. So we will also have new technologies with 5G, like stateless functions in there, which will allow very, very high reliability functions throughout the network, not just the radio part. Again, 5G is really an end-to-end system. Multi-access, both 3GPP, so mobile and non-3GPP connectivity will be seamlessly connected in there, and there will be a smooth migration from any 4G technology-enabled systems to 5G. Mission-critical communications, the 4G is already started to be used for that. 5G brings more capabilities in there with higher priority classes and application integration for public use cases. Then on the lower part, the flexible architecture is very important. 5G really brings full possibility to use distributed cloud so that we can bring the applications to the edge cloud close to the users with low latency. Very important for many transport applications that you minimize the latency between the user of the application, like automated train control, automated car control, and the cloud where the application analytics are being run. That can be done seamlessly now with 5G with edge cloud integrated into the 5G network. On security and QoS, we'll have more flexible quality of service management, so we can more flexibly manage different traffic classes in the network, and we can really separate the critical from non-critical data, guaranteed separation, so we can, in the same network again, service both, let's say, consumer applications and critical applications, and improved security over 4G. Slicing is a very, very important new technology which comes just in 5G, has not been in 4G or previous ones. And that is that what basically does is that it makes networks like cloud did for data centers. In the data centers, you had many different computers, many operating systems running on different computers for different applications. Now, with slicing, networks will become the same. On one network, one physical infrastructure, one cloud stack, you can run all the different applications, network applications there, user applications there. So it becomes really possible to have virtual networks, thousands of virtual networks on the one built physical 5G network. Means that you can have separate thousands of different applications, quality-wise, security-wise from each other. That's again one of the key things which makes 5G really a multi-purpose network, that you can run all kinds of different applications on the same time with different classes of quality and security on it. And then high speed specifically for transport, so there are special techniques used to manage very high Doppler shifts, so we can have cars or trains moving or in the future also probably aerial vehicles moving over 500 megahertz. I say probably aerial vehicles because for the aerial cases the standardization is still ongoing, so we believe it will be there, but it's not yet done. For cars and trains it is pretty much done already. So this is about the schedule. So we have two roadmaps here. On the top you can see the standards roadmap with the different standardization releases from 3GPP. Release 15 has been finished end of last year, and now you see that on the industry roadmap that 2019 this year first networks are being opening in Korea, USA, also in Finland and several other countries, and those are all pretty much for consumer use cases. So that's the first wave of 5G. Now release 16 for this critical machine communication, supporting really guaranteed quality and low latency, that will be finished early next year. And that means by 2021 we will see applications, industrial applications based on that standard, which, for example, much better, let's say, higher guaranteed quality support for moving vehicles and other industrial applications. And the work continues. So in release 17 we will introduce improvements for this machine-machine communication into 5G. So really connecting a lot more devices with lower cost. and then that will see kind of actual use cases in 2022. Even that, after that, the work continues. For example, in release 18, we will probably get in the standard improved support for non-terrestrial networks, so low Earth orbit satellites and airplanes and drones, etc. So it will be improved all the time. It doesn't mean you cannot use 5G, for example, for drones earlier. You can certainly do it already from the very start, but there will be enhancements coming along the way also in the future. So 5G is bringing all kinds of new possibilities for transportation also. One thing which I would like to kind of end up with is that 5G, why is it so important? It is because like there are two other technology disruptions ongoing. So they are shown on this triangle. So 5G is on the lower left corner, and what it allows connecting everything. Basically, Internet of Things, Internet of Everything. You can connect everything, not just the smartphones, but everything without wires. That means you can get data from everything. What is happening there, what condition things are, roads, railways, etc. And then with 5G, you can get that data into a cloud. And with 5G, you get also the edge cloud, so cloud close to the users. You can do low latency computation in the cloud. You can store things. That's the important new thing also which comes. And the third thing which is coming, which was actually the topic of the morning panel, for many of you who were here, is AI and machine learning, which allows to process automatically then that the data and learn from the data automatically, and then close the loop by controlling again with 5G all those things at the end. So this really, these three ongoing technology disruptions will really revolutionize not just transportation but many other industrial areas, and that's the big promise that 5G brings along with these two other technologies. For this to happen, you need to have a end-to-end architecture. So in Nokia, we of course have an end-to-end architecture for 5G networks, but we also have an end-to-end architecture for supporting different industries. On the lowest layer here, you have the high-performance networking, 5G and other networking technologies. Then the multi-cloud, so both the local and the centralized clouds. Digital value platforms, for example, for industrial automation, and collecting data, managing data, and then the actual business application for different use cases. So we are also working on this. We are working on many actual examples. We are working on railways, on ports, on airports, on car communications, with many operators and other industrial partners. I'm not going to go into those because I think the panel will discuss them, and I promise to leave time to that. But I'm happy to discuss those examples also with anybody if you're interested after the session. I'll be around here. Thank you very much, and looking forward to an interesting panel.
Thank you for this this overview that you have given to us about what is 5G. I think that it is already a first scan, and what can do 5G for transport. Thank you for this. I would like to go to the second part of this session. So we will have several presentations on, let's say, projects with solutions for different modes. And I would like now to invite Mrs. Anna Tsanatakaki from the University of Brussels, who will present to us the EU-funded Project 5G picture and a proof of concept of 5G solution for railways. I will ask you to stick to 7 minutes so that we can have a discussion, sufficient time for discussion during the roundtable. Sure. Thank you. The floor is yours.
Thank you very much. Good morning, everyone. Thank you very much for the invitation to present to this session. It would help my timing if I could get my slides. I have to push this button. Okay. Oh, and I did the wrong thing. I moved on. Okay. The first was the title slide, so it has been already introduced. No need to go back. I will say a little bit about 5G Picture. 5G Picture is a phase 2 5G PPP project. We are working on transport solutions that deploy converged wireless and optical networks to support a variety of use cases and applications, in fact, a variety of vertical use cases. And today I will say a little bit about the work we do, particularly on the side of railway type of use cases. So focusing on the rail vertical. The idea is to provide a network that can support the requirements of the rail systems, being on board, network connectivity onboard to trackside and trackside to operations control center. Here you see a simplified version of our data plane, so the converged wireless optical network and supporting the requirements of the rail. Some of the concepts that were introduced from very nicely from the previous speaker are very relevant to our architecture. So we're looking at concepts, architectural ideas like centralized and distributed cloud, so MEC type of architectures to offer the benefits that you heard before. The novelty so we are concepts like AI are very relevant. We are working on integrating in our system some type of data management platform offering the capability to process data using intelligent artificial intelligent approaches. And I will move on quickly to my next slide. So in the framework of the project, as I said, we have been working on developing architectural principles and technology solutions, and we are now going towards the end of the project, and we're working on the implementation of a specific rail demo that is happening currently. It will be, the final demonstration is scheduled for November this year. So here you see the location is based in Catalonia, Spain. What we are working on is on the infrastructure of the local operator FGC. We have trains. The maximum speed is less than what you heard before. So it's an operating 90 km per hour type of train. In our demo, we have involved 3 vehicles and with a capacity of 780 passengers in total. And the services we will show over our infrastructure is internet connectivity to passengers and CCTV type of services. Okay, just to give you an idea of the specific segments of the network we have implemented, we have millimeter wave track-to-train solution. So here you see the train. This is a simplified diagram. Both directions are supported. We have millimeter wave connectivity from the track to the train, and we have towers with double modems addressing both directions. The network components, you've seen the connectivity to the train. We have track access, what we call the track access network, which is connectivity along the track. For this, we adopt millimeter wave access points. We have, I mentioned already, is a fundamental principle of our data plane architecture. An optical network in fact, is an optical wavelength division multiplexed, high capacity optical network for transport capability. And then we have Ethernet aggregation level, basically Ethernet technology to provide aggregation from the millimeter wave to the optical transport. Then we have the train communication network, so basically the segment on the train, on board, facilitated again by the millimeter wave modems, 10G capability within the train along the vehicles. And of course the service equipment to support the services I already mentioned, being broadband internet access and CCTV. Right. And now you see the infrastructure. So this is actually the physical location. Here are the locations that we will, it's already in place, located the towers that will provide the connectivity. And in the interest of time, I'm moving on very fast. So what we have here is actually a simplified version of the topology. So basically, these are the modems, connectivity to the cabinet, and along the track, the passive optical, high-capacity optical network. This is a diagram of the on-train network. So basically, we get the connectivity through the wireless, the millimeter wave modems. We have 10G Ethernet capability, so 10 gigabit per second capability here. And we have each one of these devices dedicated to each one of the vehicles. The key objectives relate quite a bit with the points that were made earlier on. So, there is specific technology that we have implemented. The architecture is quite generic. The project architecture is quite generic. So I will say a little bit about the technology we deployed for the rail demonstration. The idea is to demonstrate the performance of the millimeter wave links, which is part of the novel technology we have brought in, keeping a very close eye on the total throughput, latency, and jitter. Of course, it's wireless connectivity. We need to worry about weather conditions and assess this, the performance under adverse weather conditions. Build a new train access network, which I showed you before, is this converged environment of wireless and optical, high-capacity optical network, and demonstrate principles like, for example, slicing to be able to provide different types of services. In this case, we have a limited set of services, but of course, this can be expanded to also mission-critical services and other type of services very, very relevant to the railway environment. Just to give you an idea of the real implementation, here are the modems that I mentioned before. And here are photographs from the installation activities on site. Before I finish the presentation, and I'm not sure how well I'm doing with time, but I will say something in a few seconds. We beyond 5G picture, which is finishing March this year, we have already started our new project focusing a lot on rail. It's called 5G Victory. Again, we are looking at a number of verticals, but a big focus is on the rail. This will be large-scale demonstration exploiting ICT 17 infrastructures, 5G Genesis and Eve, plus the 5G UK testbed we have available from the University of Bristol. And in terms of, so here there is a larger variety of services focusing also on mission-critical voice, video, and so on, data and signaling. And the rail operators involved is Deutsche Bahn in Germany, Trenosé in Greece, and Network Rail as a subcontractor in the UK. So that's everything I wanted to say.
Thank you very much for this very interesting presentation about 5G for railways. Thank you. I would like, we will have maybe time to ask questions to the speakers just after the round of presentation. So I would like to go directly to the next presentation and invite Mr. Jussi Apola from the Center of Wireless Communication to present the project on 5G for drones.
Okay, good morning, still morning. So this project is called 5G drones, and it's actually a phase 3 trials project of the 5G PPP. And since the topic was basically what can 5G bring to each mode of transport, I'm addressing what 5G can bring to drones. So the project is 3 years. We have 20 partners all around Europe here. And it's 12.8 million euros as a size, so it's quite significant, and it has essentially two big main objectives. So validation and validation. So validation of 5G key performance indicators for using unmanned aerial vehicles, and the opposite side of the coin, which is validation of unmanned aerial vehicle KPIs using 5G. So for the project, we have 4 different trial sites. So we have the 5GE in Sofia Antipolis, France, and we have the 5Genesis in Athens, Greece. In addition, we have our 5G test network at the University of Oulu in Finland, and the Aalto-X network at the Aalto University in Helsinki. So, going to the actual topic is what can 5G bring for drones? So the first and the biggest benefit is safe and secure incorporation of drones into the air traffic. So unmanned aerial systems traffic management, UTM. And here is where many of the 5G key components will play a part. So first of all, the traffic management operates in its own cloud somewhere. And by using the 5G network, there are 2 different slices created. So one slice for command and control traffic, and one slice for the actual data that's going to be transmitted. So why is this important? So the importance comes from the isolation. So when we create a slice for command and control communications, we can guarantee very low latency traffic that is safe. It cannot be touched by any other communications. Even actually, it cannot be even seen by any other user of the same 5G network. So it is isolated and and there are guaranteed end-to-end delivery times and guaranteed resources to be used. Well, actually, the same applies for data, but of course, when we are talking about drone data, which is potentially very high capacity, so basically it has another separate slice, and its operations, they are not as critical in terms of latency and reliability, but they demand much more bandwidth. So the drone operator actually doesn't have to see the drone. So what this really enables is beyond visual line of sight communications, and that's extremely important. So nowadays, when you drone operators, they're using proprietary technology when they're using or making beyond visual line of sight communications. Of course, you need to do planning. You need to do planning in the future as well, and you have to do your risk assessments, etc., and apply for permissions. But using 5G technology, there is no end to coverage, so you can safely operate your entire flight plan without risk of losing connectivity to the drone, and this is one very important aspect. So the second one is that there are new use cases that can be enabled by utilizing 5G. And this applies especially to public safety. So, for example, if there is now I need you to go back a slide. So thank you. So in case of, let's say, forest fire, which is applicable all around the world, there are new possibilities. So, for example, fire engines, they can be equipped with drones that are either tethered or untethered. So if they're tethered, they basically are attached with a cable and they operate essentially in finite time, and they act as small cell base stations for other drones in the network and also for the firefighter brigade in order to rapidly and in real time coordinate this kind of forest fire situation. The other is disaster management. So of course, when we experience a significant natural disaster, the topology and actually the network breaks down. So one of the key features of using drones is that they can bring emergency coverage to situations where the infrastructure has been torn down. So yet again, by using vehicles with either tethered or untethered connectivity, basically they can provide a wireless backhaul link several kilometers back to, or tens of kilometers even, back to a network that is still functional, and that in that way offer emergency services even in disaster scenarios. So the last one, not the least, is enhanced services. So there are already quite a few drone applications existing. What 5G can do, it can enhance those services. So one of the important aspects is, for example, use of 5G location capabilities. So we can operate the drones indoors or in other locations where the global navigation system is not accurate enough or precise enough, or it doesn't even exist. So, of course, enhancing the service is UAV enhanced IoT data collection. So, for example, we can deploy IoT devices in remote areas and we can collect the data using drones. Again, here our slices play a key important part. Also, another is that you can move the actual application to the edge cloud and provide the service that provides you real-time, high bandwidth applications. So this is briefly. We can be found from the internet or other social media sites. So please follow us. Thank you.
Thank you very much. Very interesting. I would like to move on directly to the third presentation, and I would like to invite Mrs. Laetitia Zarcan to join us, International Relations Manager at SES. And she will speak about satellite 5G technologies for all transport applications.
Thank you. So SES is a global satellite operator, leader in the space industry, and hiring more than 2,000 people around the world. Our end-to-end network is based on space assets, and this is a differentiator because we own more than 70 satellites covering 99% of the planet. Our unique combination of multi-orbit satellite fleets in both geostationary and medium Earth orbit is able to support and accelerate 5G rollout worldwide. More specifically, medium Earth orbit is 8,000 kilometers from the Earth. It allows high capacity, but especially low latency for automated transport. Our scalable and automated network of the future can seamlessly be integrated into all networks, including terrestrial. This is what makes satellites the virtual fiber of the future. Satellites bring ultra-reliable connectivity with low latency. It makes them essential to enable the digitalisation of transport in a society that will be more and more connected. Ubiquitous means anywhere, anytime, which is a key feature for enabling connectivity of mobile platforms simultaneously from unmanned air, sea, and ground vehicles to become effectively autonomous. During the previous panel, Mr. Van Tom from ACEA shared its concern about the connectivity that will be temporarily switched off when a vehicle crosses a border, for instance, and that will reconnect to a foreign network. This is not the case for satellites because the beam covers all the territory, no matter what the borders are. Our satellite networks infrastructure covers all of the surface of the Earth. We are able to build an end-to-end network solutions based on the cloud and software. As of 2021 and beyond, we are expanding our satellite fleet, hence enabling massive amount of capacity for the future. While doing this, we keep considering two key elements crucial for a smooth development of the networks. The first one is legacy. We have existing systems, we work with them, and we maintain them. The second one is integration. New networks will be developed, and we are aware that a smooth transition is required. We are already providing services in these four areas: trunking and head and feed, backhauling and tower feed, communications on the move, and hybrid multiplay in customers' residency. Now, we are evolving toward 5G services. We focus our capabilities on integration of satellites into these evolving areas in a seamless way, especially for communications on the move. Thanks to satellites, people can remain connected seamlessly from home to the destination, including air, for instance, initially unreachable by terrestrial networks. People want to get an end-to-end broadband experience during their journey. They want a continual access to their email and more generally to a connection that is, in this case, delivered terrestrially from some parts and through satellites for other parts. Today, out of 23,000 aircraft in service, only 37% are connected, meaning around 8,000. Estimations showed that by 2035, 70% of the planes will be connected, 23% of which will be European. there will be a booming demand for capacity, and satellites will be essential for connectivity anywhere, anytime. Satellites can deliver secured, high bandwidth and ubiquitous coverage for both fixed and on-the-move 5G networks. Today, satellite industry invests massively in global networks because we know that satellites can accelerate 5G deployment for all modes of transport, with all different technologies for drones, for whales, for boats, for cars, for planes. And we support a smooth transition over the year. Thank you very much.
Thank you. I think that with the 3 presentations and the keynote we have received, we can be positive about the 5G deployment and what 5G can bring to us. And we have also, I guess, a bit understood that, and we have heard that already in the session on 5G for connected and automated mobility, 5G will be the system, or is the system of the systems. And so I think that we have had a bit the approach supported by your presentation. I am looking at the clock and I am wondering how much time we have for questions. So I'm sure that we can have some questions to the speakers, at least few of them. So I open the floor to questions to our speaker and our keynote speaker. You all want to continue and discuss with the roundtable panelists? Yes, okay, let's do it then, and then I'm sure that you can still intervene when we will have the other questions. So I would like now to go to the third part of this session, inviting all my panelists. So I would like to invite first Mr. François Daven, the General Director of UIC. I would like to invite Klaus Werner Rüger, Senior Expert Data Link and Connectivity on Urban Air Mobility Airbus. I would like to invite Mr. Gert Dresen, MCS CIO. I would like to invite Nick Delmer, European Inland Waterway Transport Platform. I would like to invite Mr. Veli-Matti Mattila, CEO of ELISA. And I would like to invite Mr. Edwin Fischer from Dutch Telecom. Okay, I see that we have some absent. It's okay. So I would like maybe to offer the opportunity of our keynote speaker and speaker having made a presentation to join the roundtable, if they wish so. Thank you. I wonder if Laetitia would like to join and Anna would like to join. You are not obliged. Yes. Thank you very much. I propose to structure the discussion as follows. This is the first time we have such a session in our world, in the transport world. And so maybe it would be useful to first explain what are the needs of the transport sector. So maybe in few words, I would like to invite you, Mr. Daven, Mr. Rüger, and Mr. Delmer, to explain what are your needs. Please, Mr. Daven.
Well, thank you. Well, the needs of 5G for railways are quite simple. It's simply a must, because we have within the ERTMS system and for the radio communication in rail 2G system, what we call GSMR, and in 10 years from now, GSMR is over. So we must go into 5G, because it doesn't make sense to invest, for example, in 4G when in 2025, when we will have the first investment in the new generation, we will have a fully operational 5G as it was demonstrated by Nokia. So we must go to 5G. But in the same time, that's a huge opportunity. And as you perhaps know, GSMR, which is a 2G radio feature is a creature from UIC, and we are preparing the new creature, that will work on 5G, what we call FRMCS, Future Rail Mobile Communication System. So we have completed the specification for this new system, and we will entering into the demonstration phase, hopefully. With ASH 2020 financing to build demonstrator in collaboration with the industry. So it's a must, but it's also a huge opportunity, and I think there is three main opportunities within 5G and FRMCS. The first opportunity is to bring to the rail system an actual data backbone, because today with 2G, you know that the throughput on 2G is maximum 32 kilobits per second, but with 32 kilobits per second, there is no way that we can implement all the brilliant technologies that were explained by Nokia, and in particular to bring into the rail network some kind of intelligence. Because that's what we want. We want to have a more clever rail network. We want to interface with other modes, and for that, we absolutely need to have a high throughput. And there is also the question of automation. We want to go into automation in railways, and for this kind of critical application, we need absolutely to have 5G on board. And on top of that, we need to have specific bandwidth reserved for 5G within railway, as we already had with GSMR. Well, the prospect, as we should still have a 5 megahertz bandwidth in the 900 megahertz bandwidth, and we hope that we will have a 10 megahertz, a 5 megahertz bandwidth in the 2.3 gigahertz frequencies. That will be absolutely necessary for due to the criticality of, for example, ATO for high-speed train. The second big opportunity is to have today a very high level of standardization. It was already the case with GSMR, but it will be even more important with 5G due to the versatility of the system. So we are working in very close collaboration both with ETSI and with 3GPP to be sure that FRMCS, which is a 5G declination of 5G, is as standard as possible. We want to have it really a standard 5G feature to be sure that we can benefit of the continuous improvement of the system. So that's a very clear opportunity. And we consider also that 5G development is an opportunity for the rail system to become smarter and to have a better definition of its interfaces, because, well, as I said, we need to switch from 2G to 5G, but in the same time, we have a rolling plan for the implementation of ERTMS, the European Signaling System, to a significant part of the network. And there is a prospect that this implementation in the next 5 or 7 years will be with a radio that will be GSMR, say 2G. So if we want at the railway level to preserve the investment, we need to have a clarification of the interface between the radio system and the traffic management system. And that's something we are working within UIC. It's a project called TOBA. There is also a project within the sector which is called OCORA, which is about standardizing the interface between radio and traffic control management. So the idea is to have a transition that will be as far as possible, plug and play, and that will be able to continually increase the level of services. What was demonstrated by Nokia, I will not come back to that. It's extremely promising in terms of servicing, but we need to have this flexibility. And the last thing is indeed multimodality, because having a smarter data backbone means that we will be able to implement multimodality at a level that we don't know today. And 5G, from our point of view, from the rail sector point of view, is really the main enabler for very efficient multimodality. So that's it.
Thank you very much. Mr. Rüger, what are the needs?
What are the needs? Yeah, I'm representing today Airbus Urban Mobility, dealing normally with air taxis, like what you might have heard already, CD Airbus and Vahana, our demonstrators, which have been built in the US and in Europe. But I think for 5G, I can speak also a bit more generic from the Airbus point of view about our portfolio of platforms. So I think the mobile networks are really key to connect aeronautical vehicles. And I have in mind, as I said, not only the drones and the air taxis, which will come for sure, but I also have in mind other platforms like helicopters, for instance, where it is naturally quite difficult to install satellite communication in the past, since we have the rotor, which is turning above the satellite antenna and which interrupts the link. So here, clearly, this kind of new technologies can make our lives much easier to have broadband connections to helicopters, for instance. And I'm talking about missions for police missions, EMS, emergency medical operations, and things like that. And also, of course, mission-relevant data. For drones and flying taxis, it's obvious we could use this kind of networks for mission-critical communication to have the command and control link. But also an important point from my point of view with 5G is positioning. Since we observe in our daily life that we have more and more GPS or in general GNSS jamming and spoofing. This is a very critical thing for us, and technologies like 5G can give us really a backup means or a second means for navigation and positioning. For this, it is for sure very useful. And also, of course, to connect what we heard already in an earlier presentation today to the UTM, to the unmanned traffic management system, which we need to manage all these new vehicles in a common airspace. But also for large aircrafts, 5G can bring a big benefit for air-to-ground communication as maybe a natural evolution of the European aviation network, which we have in Europe. But we also see lots of movement in China by all these major Chinese operators to investigate in air-to-ground connectivity in 5G. And I'm convinced we should do something similar in Europe as well. So the main features for us, for our flying platforms, we need, and 5G is of course network slicing for the command and control to make it reliable. And I'm very happy to hear figures of about reliability and availability of 99.999%. This sounds good. This is promising, and here we need to go in a further discussion what we can do. We need to balance here between autonomy and connectivity, of course, to find the right balance for that. Beside the network slicing, the ultra reliable low latency is very interesting for us, and the CV2X for vehicle to vehicle communication, for instance, to make sure that drones and air taxis know what's around, to be aware of other traffic around, which is a quite critical thing, of course, for us. And we expect the main benefit from smart antenna base stations or beamforming, especially for platforms operating at higher altitude. I think this is, compared to 4G, is a big benefit to go to higher altitudes. So in general, higher quality of service, I think that's what what will come with 5G. That's what we expect, and higher bandwidth connectivity. But from our point of view, it is important to have an SLA behind about quality of service, especially if it is used for this kind of critical communication like command and control, that we can really rely on that. Okay, and since this is a meeting from the European Commission, allow me please one sentence concerning regulation. I think what we also need from our side in aviation, we have still some restrictions in the use of some bands. I think we are on a good way to remove the restrictions for mobile. The sentences or the keyword is mobile except aeronautical mobiles. Here, I think we need to work on that to get the restrictions as far as possible removed. I think we are on a good way for the frequencies below 1 gigahertz, but we see a need for the mid-band frequencies below 6 gigahertz to really work on that, especially on the 3.4 to 3.8 gigahertz band to get this removed. And here we are seeking the support of the European Commission as well. Yeah, that's it, mainly from Airbus.
Thank you very much. If you don't mind, give the floor to Mr. Delmer for the need of the inland waterway transport.
Thanks for having me here, but I will surprise you. I'm not as knowledgeable as these people are all around here. So I attended, at least I had the intention to attend the session this morning. I partly succeeded. I was late because I went looking for a book, 5G for Dummies, but I couldn't find one. So, but I attended most of the session, and the basic knowledge, like Laurie was explaining. Where is Laurie? There. I got that on beforehand, so I know a bit what I'm talking about. In the session this morning, what I heard was, of course, about 5G and projects around about 5G and about cars and road operators and cars and urban areas, but nothing about inland navigation. Probably because it's our own fault. Maybe we are not in the spotlight yet. That can be true, but time will come. Let me explain a bit about inland navigation then. Inland navigation is about passengers, water taxis, water buses, what have you, kind of a new market, but it's also about the growing market of river cruises, but it's also about transport of goods. And if you consider the whole of Europe, inland waterways or inland navigation takes up about 6% of the freight transported within Europe. This is if you look at the complete Europe. Of course, in Spain, Italy, there are no rivers or not exploited rivers, so there the percentage is 0. So, but if you would look at those countries where the Rhine is and the Danube, then the percentage goes up to 30-40%. Those if you concentrate in those areas, inland navigation is really big. To come to your basic questions, my answer to the questions, what are the needs, is even more simple than what these previous two people said. The people, not in the field, but on the water, tell me, give me 5 minutes of any G across Europe, and then we would be happy. Why is that? For many of our members, the vessel is their factory, but it's also their home. So to put it a bit in a funny way, a lot of skippers, while they are sailing or when their wife or somebody else on board of the ship is peeling the potatoes, they have to make a phone call in order to see where they can find another load, or in order to make an appointment with the doctor because the baby is ill. So if they don't have any coverage somewhere in the northern part of Germany where they are sailing, then having no network at all is a big problem. And often, so I've been told, these mom and dad shops, they operate with 3G phones or 2G phones. So if between now and a while these 2G and 3G networks disappear, they are completely out of business, let's say. So the basic need is coverage across Europe 24/7, so at least they can still operate with the simple communication efforts. Does that mean that this is the state of the art in inland navigation? No. inland navigation is the least visible transport mode, the most romantic one, the most idyllic one, and maybe the most Calimero one. But it does not mean that nothing happens there. There's serious research done, there's serious innovation done on autonomous sailing, autonomous mooring, semi-autonomous sailing, what have you, building new engines that meet the climate requirements in the next few years. All this is done. So probably we cannot escape. We will need 5G as well. I cannot not explain like these two people why, and definitely not from a technical point of view, but from the viewpoint of the barge operators. If they want to stay in business, they will need 5G, that's for sure. If we look at it from, let's say, also in the earlier session, I heard, and I don't see her here, Jacqueline, from the toll operators or road operators. She was explaining what they would need. Well, in inland navigation, we have a same kind of authority, let me call it, the river commissions. There's the Rhine River Commission, there's the Danube River Commission, and they are driven by the member states along the banks of those rivers, and they organize, regulate, deploy things, let me call it things, that make sure that sailing along those rivers is safe, is secure, is well organized, is reliable, all what you wish. And since many, many years, they have a perfect network for doing that based on radio communication, VHF or whatever it is. So maybe not the modern, most modern technologies, but it works and it works well. And maybe it's even more performant than what we know today in road and things like that. So one day there, the question will come as well, is this still sufficient with all this coming? So I'm pretty sure that the people working in this river commission will make the analysis towards if 5G is a necessity and where. But there are other topics to tackle then, and it was briefly touched this morning. What if you switch to 5G and there is more and more data transmission? What do you do with cybersecurity and topics like this? So all these topics are really surfacing already, but maybe as in navigation we should do our lobbying work a bit better, or digging for money a bit better, and make sure that, like there are 5G projects for cars and buses and drones and rail, that we finally get some money available to 5G projects for inland navigation. And I think some colleagues here working for Belgian authorities wouldn't mind helping me in doing that.
Thank you very much for this feet on the ground explanation. Feet in the water. Feet in the water. Mr. Fischer, may I ask you to reply to the needs expressed from the railways, from the air, and from the inland waterways?
Yeah. Okay. Let's start with the waterways in such a way. It's like if you probably mentioned correctly that it's nowadays they can be more or less lucky if they only have something like 2G or 3G coverage. But addressing the issue which was brought up also during a previous session about, say, network retirements. Of course, we are talking about having a plan for 2G, 3G network retirements over time across Europe, and it's also happening across other geographies. And you might be aware of some, say, early indications that 3G might be switched off earlier than 2G. That is more or less kind of common sense, across Europe. But there is some, say, disturbing voices, for example, coming from Switzerland saying we're going to switch off 2G before we switch off 3G. That's Swisscom in Switzerland, which is the biggest operator there. It's some disturbing voices in such regard. But what I can tell you from my company's point of view, and I hope that, say, probably a majority of other network operators and groups might chime in here, is that we are looking for complementing today's 2G, 3G coverage with a 4G overlay, finishing that. And that means, like, wherever you have 2G coverage and also going beyond closing white spots across the board, across Europe more or less, closing these coverage gaps, it will be done primarily currently with 4G. That is my first message. So the prerequisite for switching off any network technology means like you have at least the same or even better coverage with 4G and ultimately 5G. So that is more or less for setting the scene here.
And 100%.
So, well, and we are nearing. We are getting closer to that 100%. For example, if you take the Netherlands, which is of course an easy case in comparison, this is where you almost have 100% coverage. There might be still some spots, and that is an issue, like Northern Territory in the Netherlands. But nevertheless, in overall, you can have a very high degree of, say, close to 100% population coverage, and then in the high 90s in terms of area coverage. So that is kind of a baseline we are looking for. Of course, it's more challenging in the, say, alpine regions, for example.
There are no rivers.
From a river point of view. But nevertheless, railways and drones, that is also a topic there, and probably drones might be kicking in for say, delivering in any kind of alpine services, both in search and rescue, but also for logistics and supply to any kind of alpine recreation areas and so on. So there's probably enough space here. But what I want to say is, by mentioning 4G, and this is all about 5G now, it's like 4G and 5G have to be seen integrated. So the 5G deployment, the current deployment is an MBB evolution, eMBB. That is just mobile broadband, massive broadband. That is the evolution we'll put on top with 5G coverage complementing the 4G network. And then we will evolve the 4G networks, especially the core network, which will provide the necessary functions for all the famous slicing aspects we have been talking about previously. These are going to come with a 5G core. So in other words, we currently have a 4G network with a 4G core, and we are attaching 5G new radio base stations. And over time, we will evolve the 4G core network to include all the fancy 5G core functions which provide the flexibility which is required to have network slicing and more or less having virtual networks on top of one physical network. And by saying one physical network, you could think about, wait a minute, just one physical network per country? Yeah, that is also one possibility how to see it. You could even go to very advanced features of, say, network sharing between network operators, really like going ultimately to one shared physical network. That is possible. Still, you can have all the competition with licenses and frequencies and spectrum and all that stuff. So there is more opportunity going beyond site sharing, radio access sharing, and so on, by really moving to sharing physical network and having a number of logical networks, which again can have multiple slices supporting all kinds of sectors in the transportation area, but also other areas in terms of verticals, industry, but also including massive broadband consumer connectivity. So that is my take on that one, coming from the waterways. But please.
So can I go now to my members and say in 5 words, don't worry?
Well, it's like, okay, it's always the future, right? And I'm referencing to, for something which is about to come. What I can confirm is we have a number of activities which are aiming at closing the coverage gaps on terrestrial. And that is across Europe. That's not just something happening, say, in for example, in Germany. That is also happening going towards Eastern Europe. You mentioned the Danube waterway system. So in such regard, I believe there is now high pressure on it, on both from both national regulators, but also on the European level, on closing these gaps.
But
If you don't mind, I would like to give the floor to everybody, but we can come back to the discussion later on. I would like to have also your views, so that we can, Mr. Oksanen, about the needs explained earlier. What is your own view about the needs?
Okay, thank you. So, of course, like the people who operate the different industries and different transportation systems, they know the needs better. And I'm really happy that they, both from the automotive side and the railway side, are coming to 3GPP to push for these needs, so we can take them into account in standardization and provide standardized solutions for the scale benefits and plug-and-play benefits. And also we have like satellite companies, we have there as you saw maybe on the slide from the speaker, also 3G. And so that's really important that we have all those representatives, all those industries who want to use 5G, that they come in to 3GPP where it is being defined and bring in the requirements, and then we can fulfill the requirements in standards, and then they will also come into products. So that's the most important thing. What I can say about the needs as we see them is that we really work. We have projects with practically every mode of transportation. You saw also the drones mentioned. Nokia was mentioned there in different parts of the world, and we are getting a lot of experience from those projects. And main thing is really people, what I see is that people want reliability in the coverage, availability, so as mentioned here many times. And this is of course something which we do as a vendor as best as possible to include the enablers into technology, and then it is ultimately then the people who build the networks to build a sufficient coverage, whether it's public networks like Deutsche Telekom, or whether it is private networks like railways may build their own network like with GSMR. So it is ultimately a combination. With technology alone, we cannot guarantee 5 nines or something. It's always the technology plus the deployment themselves, which are the important things, and that's why we are really working with all those different sectors now, so that we can come together with a good conclusion in the end.
Okay, thank you. I would like to give 2 minutes the floor to Mrs. Zarkan to, from what we have heard from the needs we have heard, how can satellite help?
So, can you hear me?
Yeah.
There are different aspects. The first one that you mentioned, it was the fact that we are developing KPI. My co-speakers also mentioned it. We are developing cases that will help everyone to understand how to implement this technology with other kind of networks, with mobile networks, with fibers networks, terrestrials, etc. How can we help drones and planes and maritime transport? We can help them by beaming some connectivity everywhere in the world. As I mentioned, 99% of the planet is connected. It's trans-border. It doesn't take into consideration the different politics, etc. It's just connected, just beams. So this can be a solution for the maritime sector, for instance, for the planes. And the low latency also prevents any additional time between the order given and the order received. This is also a very important aspect that we took into consideration while deploying our MEO, Medium Earth Orbit, constellation, because this is a unique network, and this is because you mentioned your concerns that we managed to develop them. So thank you very much for your inputs.
Thank you. Mrs. Tsanakaki, apologize. Could you react a bit also on what you have heard and share a bit your experience? Could you add something to what you have heard, especially from the intervention of Mr. Daven?
Sure. We are positioned on the research side. So we're trying to identify future needs and try to look at technology in the forefront of it. So paying a lot of attention in the requirements coming from transportation, in this particular case, industry is very, very important to us. I think we have been working, and you've seen one example of the work we have been doing. We have been working very closely with the rail industry. In fact, Deutsche Bahn is one of our partners in the latest activities we have. So we understand that there is a variety of services that need to be supported with very, very different requirements, mission critical being a very central one, for example, for ultra low latency and reliability and so on. So we're trying to see how one common infrastructure will be able to support all this variety of services, and we're looking at fundamental principles, architectural principles, like, for example, slicing. We're looking at ways to handle and provide the intelligence required, so do processing of collected data. For example, for rail, which is the industry we're very close to, we have seen that there is a lot of interest in metering, energy metering, and so on. So there is also this data crunching that has to happen somewhere. So models like, for example, distributed cloud, which was introduced in the plenary talk, are very relevant. So we're now trying to find architectural solutions that bring all this together. We have some already in place. And when I started my talk earlier on, I said that we're working on a 5G solution which converges together optical and wireless network. And today, I think in this session, it was said that 5G is an end-to-end solution, and I would like to highlight this. And I think this is a big step from 4G to 5G, right? So instead of looking at the wireless access domain very intensively, we still look at this, but we made the step towards this end-to-end. So now other network technologies come into place, and I think the message in the morning, 5G being a system of systems, I would say a network of networks, comes very much into the discussion. And I think that would link to the previous point, right? So, for example, we have very intensively been looking at integration of wireless and optical technology, fiber terrestrial type of technology, but we certainly are looking very, very intensively into bringing in other network solutions like satellite, addressing specific requirements from other industries, like, for example, maritime or...
Would you like to react? And then I think that I would like to give the floor to the audience. So we need, yeah.
Just indeed a very short comment that indeed the FRMCS specification is beamer independent. So that means that it's embedded within the FRMCS specification. One of the use cases is satellite because, UIC, we have a lot of European members, but we are a global organization, and there is part of the world where indeed satellite will be the preferred solution for control command system.
Thank you for this reaction. I would like now to give the floor to the audience. Do we have... Yes, I have a request over there. You will receive the mic.
Yes, thank you. I am one of the taxpayers that is providing the 700 million euros for the Horizon 2020. And I hear today, which is the PPP part of, I am here today listening a lot of sales speech of a wonderful technology, but I wonder why I don't have it yet in my mobile phone. So I heard maybe there are national requirements or maybe ETSI standards to need be developed. I would like to see more concrete, what is the stoppers for this? Or it's not a cost-beneficial technology, nobody wants it or buying it. I want to hear more about that.
If you don't mind, I think that the telecom sector should reply to the request.
Okay, so as I showed, like the standard for 5G, if we talk about 5G now, of course 4G is almost everywhere. But 5G, that was finished end of last year. So and now first networks are opening. So this is actually faster than in 4G, and the subscriber base is increasing faster than it was in 4G if we compare from the end of standards. In Korea, where they have the biggest networks built, I think they currently have already 4 million users with 5G phones. So definitely there are phones, and now also. As I said, in USA, in some European countries, and now also here in Finland. So you can go to the shop and buy a phone. It's of course depending on each operator when they decide to launch the 5G network and then start selling the phones or that you can connect to them. But definitely it's growing, and remember that like 5 years ago, it was expected that 5G would open for commercial usage in 2020. So we are 1 year ahead of that schedule. So I would say that it's coming fast, but obviously not every country has networks yet. And the phones, I would say that they are better quality than the first 4G phones for consumer usage also. So it's in my view, it's going on pretty well.
Mr. Fischer would like to add something?
Yeah, well, as you said, it's like we just opened networks in a number of in countries where we operate, and it's not just us, so it's across the board, and it's certainly one year ahead of the original schedule, more or less. So, of course, we're talking about, say, limited network deployments for the time being. Just think of the spectrum has just been assigned, and there is still, even in some geographies, there is no 5G NR spectrum with 3.x gigahertz spectrum as the kind of a pioneer band, more or less, where you can experience the advantages of higher throughput, significantly higher throughput, and also some significant reduction of latency. And that is, of course, talking about this spectrum, this is of course not the spectrum to go for achieving blanket coverage, say having area coverage across the board. This is spectrum which is primarily for covering areas where you have high traffic demand. And that is currently, with the current usage pattern, this is still a consumer use case in all the cities, basically. That is the start. But it's making its way into different type of transportation modes. Certainly, the railway traffic and also the user entertainment part, if you will, it grew significantly. And we cannot plug in. We are really struggling to plug in more spectrum and to deploy more network capacity in order to serve it along the big transportation corridors for passenger trains, right? But this is a beautiful opportunity for deploying the next generation of network and all this enhancement by doing it together, instead of doing it in a siloed mode, because you have to do it for your train control system for your next generation. We have to do it for a number of IoT cases, but also for mobile broadband cases, which just surge, right? So that is why by collaborating, we can probably even save a lot of money if we jointly develop the connected transport corridors for all different kind of modes. And that is my message here. And we've started. So.
Thank you. Mr. Delmero, you wanted to add something?
Yes, of course, I did some preparation before coming here, and it happens to be that our office is really next to the Brussels office or European offices of one of the major chip manufacturers. So, of course, I knocked on their door and asked for some information. And the simple answer was, the chipsets are not already in sufficient quantity available. And that's one of the reasons why you cannot go to a shop yet and buy your 5G phone. So sometimes answers can be very straightforward.
Thank you. Yes, over there is a question.
My name is Peter Barca. I'm coming from Hungary. Hungary was one of the first countries that has been nearly covered by GSM and 4G technologies. On the other side, we are rolling out GSMR now. How can you make this project sustainable from the regulatory and from the technology side, please?
Who is able to answer this difficult question?
So maybe just on the I can't say about the regulatory, but on the technology side. So yes, it is interesting, and some speakers mentioned that, like in some sessions here, that the railways is a very old technology, and sometimes things happen slowly. So and it is interesting that we see that there are countries rolling out the GSMR when some are contemplating rolling 5G in a few years for railways. Of course, from technology side, so any networks that are rolled out with GSMR, so at least from our company, we're committed to support them for the lifetime which has been agreed. So that technology side, it will be there. Obviously, GSMR will not jump to a new technology level, so it will survive those use cases or serve those use cases which have been defined for it. Then, if you want broadband, etc., you need more. But that's very clear. On regulatory side, I can't comment too much on that. I hope that regulators take into account also the need for critical services in those countries.
Thank you. You would like to react?
Well, just to say that basically the GSMR network is a private network. So if the operators stop to have to support 2G in, let's say, in Hungary, the GSMR network, as it is a private network, will continue to be operated. So the actual problem is in 10 years from now, where the manufacturers will begin to stop to give chipset and so far and so on for the GSMR. So the real, let's say, wall is indeed in 10 years. That's the reason why we are starting the development of FRMCS now, to be sure that in 10 years we will have everything ready for the transition. And you spoke about regulation. Well, I'm not sure it's really a question of regulation. It's more a question of, from my point of view, of standardization. And as I said in my introductory speech, the main question is that in locomotives, you will have the traffic management system, the part that is doing the traffic management, meaning measuring the speed and so far and so on. This one will have a duration of 20 or perhaps 30 years for some of them. But what is important is to have the interface well defined between the radio part and this TMS part. If we work, we have a couple of years to work on the standardization of the interface, changing from 2G for 5G or on those ERTMS things that we install now, that will not be a big deal in terms of investment. We need to have it as public plug-and-play possible. But I do agree that today we are not completely there. So that's the reason why in UIC we are working quite closely with the European Railway Agency and with the other stakeholders to be sure that at the end of the day we have a very well-defined interface.
Thank you. Do I have a next question from the audience? Or you are all hungry and you want to have lunch? Okay, you have a last short question.
I think the answer is obvious, but anyway, I have a brother who works with fiber optics, and he's installing, and he works in America, and I told him about 5G is the future. You should shift to installing antennas instead, no? But he told me that there is rumors that the health will decrease somehow because of these radio frequencies and the effect of it. I suppose you already researched and done this work, and it's no problem, but I would like to hear it from you.
Again, Mr. Fischer or Mr. Who replies to that?
Well, maybe I can start. So first on this fiber and 5G, of course, are not exclusive. So actually what we see that in most operators who are planning to invest in 5G, they are heavily in 5G, they are heavily investing in fiber first because they need to take the data from the cell tower somewhere. And also fiber will be still deployed for fiber to the home. There will be 5G fixed wireless access to complement that. So both will live side by side. So your brother will not be out of work. So don't worry from that point of view. But of course, we take health very seriously, and we follow everywhere the World Health Organization rules. And also some countries, they have own rules. So of course, those are followed, and the deployment of the systems in those. There have been a lot of research into health effects of wireless radiation, not by us, but by medical industry and independent medical industry. And no significant or no real proof has been found that there is short-term or long-term harmful effect when following the guidelines set by the World Health Organization. I have noticed myself also that, like in every G, there is an uptake in a kind of concern. So radiation, that was the same in earlier, and now it's you can see in media things in there. So we need to take this kind of carefully, and of course, like explain to the people what the situation is, and we don't want to dismiss the concerns, obviously, but we don't have any proof of any issues that would be causing that. So we just need to keep talking about that and listening what the real issues are.
Thank you. No, nothing to add. Thank you. So, if there are no final questions, I would like.
I have one.
Happy to have invited you. You are so active. Please.
So talking about inland navigation again, first issue is crossing the border. Today, inland navigation is very often to the ports of Rotterdam and Antwerp. To take those, so it's crossing the border very often. If we then think about autonomous vessels or remote-controlled vessels and so on, so there might be an issue. That's one issue. The other kind of concern we had when preparing for this was we talk about car, we talk about urban areas, and so on. And urban areas get bigger and bigger. So the services needed for the people in the urban areas need to be improved and so on. Will there be, in the end, time to invest, money to invest still enough in order to service all the rural areas? Will they not again be forgotten when 5G needs to be rolled out? That's a concern we really have, not for today, but maybe for tomorrow.
But that is a good one, and that is one of the reasons why we are talking about this strategic deployment initiative or a strategic deployment agenda for 5G, for cross-border seamless connectivity, basically, which is banking on 5G, on evolved 4G and 5G. And that should, since these areas are, in most cases or in many cases, they are in rural areas. So we are definitely giving specific notice to how to tackle it even in rural areas. So that kind of deployment aspects are being considered, and there might be, or there shall be some say, schemes of funding and co-financing from many sectors, basically, to make it happen. So it's not forgotten. To the contrary, I would say.
I know that there will be a roadmap for road and railways because they have been identified with the 5G action plan. Do you believe that we need to have, if this aspect will be covered in this roadmap, or will we have other roadmaps to address this rural area, or they will, with the work that will be done in the other roadmap, it will be sufficient?
I think we should consider it as well. Okay. In the existing programs, rather than firing up yet another one, because then it's by having this kind of tackled piece by piece, we create new silos and do not leverage the synergies, and that would be stupid.
Super.
My take.
Thank you.
I don't know.
I have learned a lot. May I accept another one? Very, very short. May I have the micro? Yeah.
Very short to conclude, and it's a question for Nokia. Have you started working on 6G? Or if you have not, when do you plan to start on that?
Yes, we have started. Like our CEO said in the Brooklyn Summit, which we organize with New York University every year in April, we consider this as year zero for 6G research. So we have started it, and year zero in the sense that 6G system, obviously technologies that can be utilized for 6G, we have been researching already for a few years, and this is because these are very long time cycle things. We actually looked recently that technologies that now are in 5G. Some of those technologies we have started researching already 14 years ago, and now they are coming to fruition. But again, from a system point of view, it is more like 6 years. So it is different depending on the different technologies you are using. So, but yes, we are researching on 6G.
Thank you very much. I was looking for asking my colleagues if we need to add something else, because we are organizing this session with our colleagues from DG Connect. Having said that, I hope that no, you have no question. If you have question, you follow them during lunchtime, and so they will continue to reply to your question. I have learned a lot, so thank you to all of you, and I hope that you have enjoyed this session, and I wish you a good lunch, and see you this afternoon for the other session. I know that we continue on the Digital Road Network this afternoon. I know that there are other sessions, and then we will see each other for the closing plenary. Thank you to all, and I wish you a pleasant lunch.